What are the queries available for the spatial analysis? Those things we'll see here. So basically, we'll understand the concepts of spatial data retrieval, classification, operations. The learning outcome of this lecture is you should understand at the end of the lecture the what is spatial data analysis, what is the importance of spatial data analysis, then different kind of components for spatial data analysis, steps and tools. So before seeing the tools and steps of spatial data analysis, just think about these problems like you have to find out nearest hospital, or you have to find out the route to the nearest hospital or distance to the nearest hospital, or find out hospitals within 1 kilometer region from your home. That kind of analysis, if you have to perform, that kind of query, if you have to perform, what is needed here to perform these kind of queries? Because we need to find out distance of the hospital. For that, a road network is needed, hospital location is needed, and basically a software, a platform is needed which can perform these kind of queries. There can be other queries like find out the schools which are in a distance range of 100 meters from the road, and a distance of 1 kilometer or 2 kilometer from your home, and having education quality above certain quality standards. So how these kind of queries can be performed? And suppose you do not have GIS, you do not have facility of GIS, then how these things, these queries can be performed? So if you do not have GIS, then finding out the hospitals which are within a distance of 1 kilometer from your home is very difficult task, because on ground you have to go to the hospitals nearby and measure the distance manually, that how much distance is there for those hospitals. So it becomes very tedious task. And suppose you are in some new area where you do not you are not aware about the area itself, then how will you search the hospitals? Without GIS, it is very difficult. In your present area, you can, since you are aware about the area, you can find out. But in new area, very difficult. So nowadays you are having facility of Google Map. In Google Map, you simply type nearest hospitals, and it gives the list as well as spatial distribution of hospital near to your location, and you choose the suitable one based on the ranking, based on the rating. In background, there is a concept of GIS and spatial data analysis. What is spatial data analysis? It is the process of extracting information from spatial data based on certain set of requirements. For example, you are having road data, you are having the hospital data, you are having school data. So these data sets you are having. So what is the use of having these data sets if you are not able to extract any meaningful information, any desired information? So when we find out some meaningful information from the existing spatial data, it is called spatial data analysis. So there can be parts like performing spatial queries, network analysis, surface data, generating surface data. These are part of spatial data analysis. The spatial data analysis is very, very important, because from spatial data analysis, you get meaningful information from the spatial data. What are the things needed to perform spatial data analysis? Since spatial data analysis need to perform, so basically spatial data is needed. Then how analysis will be performed? You need a platform, a computer with GIS capabilities, a computing device, you can say, with GIS capabilities, because some level of spatial data analysis using Google Map you can do in mobile phone. So computing device with GIS capabilities, then what kind of analysis is being performed? So requirement need to be defined. Problem statement need to be defined for the analysis you want, like you want to find out the schools which are 1 kilometer away from your location, or schools, hospitals which are in the range of 1 kilometer from the accident spot. Then along with that, you need to know about the algorithm and tools available to perform that analysis. There may be some cases where you know about the problem statement, but tool available, tool is not, ready-made tool is not available to solve your problem. So in that case, customization of the GIS software is also needed. At the end, since uh, you are working with spatial data, so at the end you need to visualize the distribution of your output. So visualization is also very important component for spatial data analysis. So the spatial operations are grouped under these functions: measurement, retrieval, classification, overlay functions, neighborhood function, connectivity functions. Today we'll see measurement, retrieval, and classification group of functions. First, let's see measurement. So when you talk about measurement in GIS, we talk about geometric measurements. What are geometric measurements? Like finding out distance between 2 points, find out length of the line, find out area of the polygon, find out perimeter of the polygon, then the centroid of the polygon. So these kind of measurements belong to geometric measurements. So how these things are calculated? Suppose distance between 2 points is need to be calculated. So if it is, so if distance between the 2 points need to be calculated, let's say this is point A, this is point B. So just for distance between 2 points can be calculated using Pythagoras distance formula. Square root of y2 minus y1 square plus x2 minus x1 square. Very easily it can be calculated. But when it comes to distance between point and a line, then which distance? Like suppose there is a point P and line Q, so there can be many distances possible. But you will get in GIS, if you find out distance between point and line, you will get in return the minimum distance between these two features. Same is the case for distance between two polygons. It is the minimum distance between two polygons. Like in these polygons, this is the distance between these two polygons. In case distance between this edge and this edge is possible, this edge and last edge is possible, many distances are possible, but distance between these uh, objects will be the minimal distance between these uh, features. In case of raster, things are little different. For example, in raster, if you have to find out area of certain feature, so in that case, if it is a regular raster, regular means shape, size, and orientation of the raster cells are same, which means all the cells of the raster, they are having same shape, same size, and orientation is also same. So suppose in this figure, area of the feature which is represented by yellow color need to be calculated. How it can be calculated? Count number of pixels used to represent this yellow color. So here I can see there are 5 pixels. If you divide them, so there are 5 pixels total. 1, 2, 3, 4, 5. And if size of a pixel is 30 meters, so 30 by 30 will make it 900 square meters. That is area of one pixel. into 5 pixel will become 4500 square meters. So if distance between two cells of the raster need to be calculated, that will be the distance between the midpoints of the raster, not the minimum distance in case of raster. So any measurement in case of raster, that is from midpoint of a cell to midpoint of another cell. Uh, Unlike vector, the concept of finding out the coordinate value of any cell is different. In vector, you have coordinate value stored for each point. In case of for each vertex, coordinate value is stored. For polygon, for each vertex, coordinate value is stored. But in case of raster, that is not the case. In case of raster, coordinates are stored for anchor point. And from this anchor point, coordinate of rest of the cells can be derived whenever needed. For example, here for x coordinate of anchor point is 1554 and y coordinate is 203538. So in this case, if x coordinate and y coordinate of this pixel need to be calculated, how it can be calculated? If resolution of this raster is 20 meter by 20 meter. So if you add this 20 meter plus half of the pixel 10 meter in x coordinate of anchor point, you will get x coordinate of the cell, and for y coordinate you need to subtract 10 meter because y coordinate of anchor point is this. Here is the anchor point and you are coming down for this pixel, so half of the pixel you are coming down, so 10 will be subtracted from y, and for x 30 will be added. So similarly, x coordinate and y coordinate are calculated for any cell, but they are not stored for all the cells. Anchor point and resolution is stored. For rest of the cell, it is derived whenever needed. Now we'll see about retrieval of the data. Retrieval functions facilitate searching of the data. The searching can be based on attribute value. The searching can be based on location value. For example, if you have to find out the all the cities having population more than 0.1 million. So this belongs to searching based on attribute value because you will have a city data, and in city data, city vector data, and in attribute table of that vector data, the population information will be stored. So to find out cities having population more than 0.1 million, you just have to put a query over the attribute table. So it's just like putting a query in an Excel sheet. No location information needed, only attribute, only numerical information is needed in this case. Numerical or categorical information needed in this case. No spatial information needed. But if you have to find out length of border of a country, in that case, spatial information, location of the polygon is needed. We will see how these queries are performed. So first we'll see about selection based on interactive method. There can be selection based on interactive method, then and attribute condition means non-spatial query, and based on the topological relationship, that is selection based on the location. So how interactive query occurs, how interactive queries can be used. You as as you can open the data in GIS software QGIS or ArcGIS, you will have a data view and attribute table view. So data view is this one, In QGIS also it is known as QGIS canvas. So in QGIS canvas you can see the data shapes, point, line or polygon. And along with this point, line and polygon, you will have attribute table information, which will be similar to this table. So this data, point, line and polygon and this table, they are interlinked for a file. They are related, which means if you are selecting any record, means any row from the table, the corresponding polygon will be selected in database or in QGIS canvas. Or if you are selecting any polygon here, the corresponding row will be highlighted in attribute table. So when interactive query can be used, for example, you are having world map and out of the world you have to select country India. So if since you know where is India, you can simply zoom to that location and just from the mouse click you can select. Or suppose you have to select United States. So everyone knows where is the United States of America. So you can simply navigate to that region and using mouse click you can select. The attribute queries are not needed in this case because you just have to select one polygon and you know where is that polygon. So interactive queries will save your time and efforts. But suppose you have to find out a village, you have to select a village in a village database of your country. Then it becomes very difficult to pinpoint to that village if you are not aware, because you can be aware of some villages like the village you belong to, that you will be knowing specially, or some very prominent popular village names will be known to you specially, but not all, because the number of villages will be very high. So uh, what can be done? Manual searching or interactive selection will not be useful in the cases where navigating, zooming to the location is very difficult as you are not aware about the exact position. So what can be done? Selection can be done based on attribute queries using relational operators. So here in relational operators, you are having field from attribute table and followed by relational operator, which can be less than or equal to, greater than equal to, does not equal to, followed by a value. So field, then relational operator, then value. Let's see one example. Suppose you are having some database where ward, you are having database of ward map or municipal unit of the country, and you have to select all the municipal units which are having population less than 7,000. So how the selection can be done? Suppose you do not have this facility, then for interactive selection you need to see all the values manually. So you need to uh, scroll down and see all the values manually, and wherever value is less than 7,000, that you need to just click. So if number is very high, number of units in data they are very high, then finding out manually becomes a very tedious task. In that case, this relational operator can be used. So population, this is name of the field. Here, like name of field is population. So exact name need to be written. Here it is written in caps, so caps should be written here instead of running letters. So exact field name should match here with field, followed by the operator less than then followed by a value. This will return the polygons which are having population less than 7,000. For example, first record it is having population 7,654, which is more than 7,000. So this is not selected. But for this uh, population is 6,907. So this is selected because population is less than 7,000 in this case. Now logical operators, basic logical operators are and, or, not. So and will return true if both expressions are true. Or will return true if one or both of the expressions are true. Not will return true if expression is false. Now let's see what do I mean by expression. Suppose your task is to select the polygon which is having area more than 100 square meters, 100 square kilometers, and population is less than 8,000. I'm repeating again. Suppose you have to select a ward which is having population less than 8,000 and area of the ward is more than 100 square kilometers. So, so in this case, uh, whichever ward is selected should be satisfying both the conditions. Means this is condition 1, this is condition 2. So if some ward is satisfying both the conditions, then only it will get selected. For example, this first record here, you can see area is 51.98 square kilometers, whereas our condition is area greater than 100 square kilometers. So this condition is not satisfied for first record. So this record, this row will not get selected. Then for third row, area is 145, which is more than 100. So this condition is satisfied, but population is 8030, which is more than 8,000. So this condition is not satisfied for third record. So this is not selected. For fourth record, area is 651.99, which is more than 100, and population is 7,630, which is less than 8,000. So in this case, both the conditions are satisfied. So this record will get selected. Now example of OR. In case of OR, query can be select the polygon, select the words which are having area more than 100 or population less than 8,000. So or means if either of these two conditions or both of the conditions are satisfied. So which means if any one of these condition is true or both of the conditions are true, then it will get selected. For example, first row area is 51.98, which is less than 100. So this condition is not satisfied, but population less than 8,000, that is satisfied for second one. So this condition is satisfied, this is not satisfied. So overall you will get true in return, means this row will get selected because one of the condition is satisfied. For the second record, none of the conditions are satisfied, so it is not selected. For third, area is greater than 100, but population is not greater than 8,000, but still it is selected because it is OR. So if any of the condition is true, you will get true in return. Then for fourth, both the conditions are satisfied. So if both the conditions are satisfied, then also you will get true in return. negative condition or not operator. If not is written some before some condition, which means it will select all the records except the given one. For example, here ward name equal to Rajpur. So here it is ward name to equal to Rajpur and not is written, which means wherever ward name is not Rajpur, those wards will get selected. You can see here, apart from Rajpur, all are selected. This field name should be exactly matching name of the attribute table. Here it is in caps, so here also it should be in caps. How searching for null value can be done? So if you are storing your attribute data in some databases, you will find that there is null written. So how to find out null values, or how to select the records which are having null values? So for finding out null values, these operators will not work. Less than, equal to, greater than, these operators will not work for finding out null value. For null value finding, you need to use is. So the query will be ward name or name of the field is null. So this will select all the rows or the records or the polygons which are having null value. Like operator. Like operator is used to find out the records which are having values similar to this one. For example, word name like RA percentage. So this will select the records which are having name starting with RA. This is case sensitive. So name starting with capital R and small a, that will be selected. Word name like percentage RA, which means if name is ending with RA, that will be selected. Word name like percentage RA percentage, which means wherever RA is somewhere in between, so those records will get selected from this like operator. So this is the way of using attribute queries. Now we'll see about some special relationships and see how these relationships are used for performing location based or spatial queries. So there are basically 8 kind of spatial relationships. So based on these relationships, queries are performed. So first one is disjoint. So if two geometries are not touching, not overlapping, so this is called disjoint relationship. Then meet relationship, when geometries touch at the boundary from exterior, means there is touching from the outside, no interior touching. For example, if you are having this polygon and you are having another polygon and they are meeting at the boundary from outside, this is meet relationship. There is another possibility, touching from the inside. Here these two polygons are touching at the boundary but from inside, but this is not meet. In case of meet, there will be touching from the outside at the boundary, exterior touch at the boundaries, that is meet relationship. Let's see about some questions. Which of the following is not spatial analysis? Attribute query is part of spatial analysis. Spatial query, routine creation, network analysis. Routine creation is generating surface from point data. Generating surface from point data is not exactly spatial analysis. Which of the following component uh, which of the following is component of spatial data analysis? Toposet, yes. Toposet is source of spatial data. Selection criteria, yes. Problem statement is needed for spatial analysis. Visualization, yes, you need to visualize data at the end. Basically, all of the given options are true in this case. Distance between two cells of the raster is, it is the distance between their midpoints. Minimum distance is the case for vector data. So distance between two vector features is the minimum distance between those two features. But in case of raster, distance between two cells is distance between their midpoints. So now, if like operator is being used, which of the following will get selected? Word name like RA percentage, which means name which is starting with RA will get selected. So here, this RA, this will get selected. This will not, because it is case sensitive. Which of the following is true about disjoint relationship? In case of disjoint relationship, there is no touching. The geometry is neither touch nor overlap. So this is disjoint relationship. The next, geometries touch at the boundary from outside. This is meet relationship. Geometry is completely coincident. This is equal. Intersection boundaries. This is overlap. We'll see about other relationships now. Which of the following is correct about meet relationship? Geometries touch at the boundary from outside. Exterior touching. Now we'll see about overlap relationship. So in case of overlap relationship, boundaries intersect. Basically, you will have intersecting boundaries. So this is overlap relationship. One object, one feature A is overlapping with feature B. So there is intersection at the boundary. Equal relationship. So in case of equal relationship, geometries are completely coincident, which means the shape, size, and orientation of the geometries is exactly same. So when it is possible, when both of the geometries are either polygon, or if both of the geometries are line, or if both of geometries are point, which means equal relationship is possible when equal geometries are being compared. Because, like here, point cannot be compared with a polygon. They cannot be equal. They will be having different sizes. A line cannot be equal to point because line is having length. Point does not have length. So they will never be equal. So for equal, same geometry will be compared. Point, line, or polygon. Inside relationship. Inside relationship, basically the inside portion gets selected. So for example, in this case, this outside polygon name is polygon A, inside polygon name is polygon B. So in this case, the inside polygon gets selected. The query can be select the polygons which are inside polygon A. Or I will make another example. Suppose I am having a city, and inside the city there are some schools. Outside the city also there are some schools. So if your query is select all the schools which are inside the city. To address the query, select all the schools which are inside the city. The schools which are present inside the city boundary, they will get selected. I'm repeating again because you will get confused by seeing other relationships. You are having the city boundary, you are having schools, some are present inside city, some are outside the city. But your aim is to select the schools which are inside a city. So in this case, schools inside the city, they will get selected. So this is inside relationship. In case of covered by, even if there is touching at the boundary from inside, then also feature will get selected. Now we'll see about contains. Both the inside relationship and contains, they look similar. Visually they may appear similar, but they are not. In case of contains, the outside polygon gets selected. Let's say this is B, this is A. So in this case, polygon A will get selected, not the inside one. I will draw this query. Suppose you are having a ward map of a city where you are having different wards, and one of the ward contains clock tower of the city, and you want to select that particular ward. So your query will be select the ward which contains clock tower. So in this case, ward boundary will get selected. So this ward boundary will get selected. So outside feature is getting selected in case of contains, whereas in case of inside, the inside features were getting selected. Covers. In case of covers, the boundaries meet internally. So covers is also similar to contains, but here there is touching at the boundary from inside. Similarly, covered by is also similar to inside, but there is touching at the boundary from inside. Because if there will be touch at the boundary from outside, then it will become meet operation. So here you can see there are some polygons. These polygons represent wards, and some points you can see these points represent schools. So your query is select all the schools that are located in ward A. Each ward is having some name, XYZ names will be there, and I want to select schools that are present inside ward A, located inside ward A. So first of all, ward A need to be selected from all these wards. So here, if you know specially where is ward A, then you can simply go to the location and select using interactive selection method. Means just using mouse click you can select. But there can be situation where you do not know where is the ward specially. So in that case, the attribute query need to be applied over ward attribute table or ward names. So using that query, ward will get selected. So using that way, you come from this to this. Here in this case, a ward A is getting selected. So this is ward A. Now schools inside ward A need to be selected. So inside relationship will be used here, and the schools which are present inside this ward A, they will get selected. Inside relationship is used here. Another task here, you can see the black boundaries, they represent wards, and the reddish one, they represent roads. So your task is select the highway that runs partly through ward A. So select the highways which are running through some particular ward A. So again, you need to select ward from this ward list, ward data, not ward list. So this is ward A. Now, which relationship will be used in this case to find out which ward, which highway is running through ward A? Intersect relationship. So basically, intersection of the road will be done with this selected ward. So if intersection is true, which means that highway is running through this ward. So intersection means overlap relationship where boundaries intersect. So for example, this one here, a polygon is intersecting with line. Here, no intersection. Now let's combine various selection techniques. Suppose your question is select all the major roads that are located within a distance of 200 meters from a hospital. So for this, you are having a road database where different kind of roads are present. Major road, minor road, there can be village roads, and you are having a point data which is representing different point information, hospitals, schools, banks, government buildings, secretariat. So different buildings are represented by these points. And now you have to select the roads which are located within a distance of 200 meters from the hospital. So in such cases, you need to break the query in different parts because directly you cannot select the roads from a 200-meter distance from hospital. So if road having 200-meter distance from the hospital need to be selected, which means first you have to select hospital at least. Then only from the hospital you can select the roads. So from this point data, you need to apply attribute query to select the hospitals. If there are few hospitals, one, two, then you can simply using interactive method you can select. But there can be multiple hospitals in the region. So for that, uh, attribute query need to be performed, where the building type is equal to hospital. So those points will get selected. So these yellow color points, these are the selected hospitals. Now, since 200-meter distance roads need to be selected from these hospitals, to select roads which are within a distance of 200 meters from the uh, hospitals. So, which selection query will be used here? Intersection or overlap can be used, or within inside query can also be used if there are small road segments. So select uh, select using location, selection using topological relationship, a special location based selection will be used, and within that uh, overlap relationship will be used to find out the roads which are within a distance of 200 meters. So this will select all the roads, the major road, minor road, district road, village road, colony road, all the roads will get selected. But your task was to find out major roads. So now you have to again filter out these selections using attribute selection. So select the major roads from the selected road. So again attribute query need to be applied. Now interactive selection cannot be performed because selected road number of selected roads will be high in this case. So performing interactive selection will be very difficult. So attribute query will be performed over the type of road column in road attribute table. So this will return the roads, the major roads which are within a distance of 200 meters from the hospital. Now we'll go to classification group of functions. Classification, reclassification is about assignment or reassignment of the classes based on the attribute data, attribute value, that is in case of vector, reassignment or regrouping of the pixel based on pixel value in case of rasters. Why do we need to perform classification? Classification is performed to remove the details from the data and reveal the patterns. For example, if you are given the satellite imagery where pixel values are representing a continuous field phenomena, each pixel value is having different, each pixel is having different pixel value. So if you can classify the satellite data, so easily you can find out where is built-up area, where is river body, where is forest area, where is agricultural land. So that way classification, reclassification helps because it removes the detail, pixel-wise details are removed, but overall patterns you will identify. For example, in this case, in these two figures, the left hand side, it is representing population density of each ward. Just assume it is representing population density of the ward. So each ward is having different population density. Hence, each ward is displayed in different color in this case. But can you find out any pattern here? Can you find out which region is having more population density, which region is having less population density? Which polygon is having more population density, which polygon is having less population density? Even in this image, there is a possibility to have a legend where size of legend will be very large, corresponding to each value there will be color. So for each value of population density, there will be one color. So looking at the legend and finding out which color is representing which population density, it becomes difficult. Easily patterns cannot be seen in this kind of representation. But the moment the population density is grouped in low, medium, and high classes, and now you can see, you can easily find out, oh, these are the pixels, these are the regions, these are the polygons, these are the wards having population low, population density low, and these are the regions having high population density, and these are the regions having very high. These are the green color, they are having high population density. Red is means they are having medium population density. So this is the use of classification or reclassification. Sometimes you need to classify, reclassify based on the purpose. Like you are having different kind of soil types present, and for example, if your task is to find out the suitable location for growing wheat, so for that there will be, for wheat production, there will be some suitable type of soil like alluvial soil. So all the soil categories can be grouped under suitable category for wheat production and non-suitable category for wheat production. So this way you will get two classes. Soil type, you focus here, soil type is itself a classified data, and you are classifying this classified data in suitable and non-suitable. So this is called reclassification. Classification of classified data is reclassification, that is done to fulfill the demand, that is done for some particular purpose. If your task is to grow tea or coffee, so in that case there will be different need, there will be different kind of soil suitable for that tea production. So based on the that favorable soil type, suitable and non-suitable category can be made. So this classification and reclassification can be done manually as well as automatic classification is also possible. Uh, Manually means you define the interval. For example, if you are having elevation image, digital elevation model, and you want to group the pixel values, elevation values in low elevation region, high elevation region, medium elevation region, and very high elevation regions. So the classes range of pixel values, for example, 0 to 400 meters is low elevation region. 400 to 1000 meters belong to medium elevation region. So these class intervals, if they are created manually, then it is manual classification method. Or you can have a table for this kind of classification. So classification based on the table. Then there is a possibility of having automatic classification based on equal interval. So in case of equal interval, you just you give input image or column of attribute table and give number of classes. For example, you want your image to be classified in 5 classes. So depending on the range of values present in your image, it will divide the interval equally. So equal size of intervals will be formed, like 0 to 500, 500 to 1000, 1000 to 1500. So width of the interval will be same in case of equal interval classification. There is another classification method, equal frequency classification method. In this case, Number of pixel in each class, they are same. So classes are made in such a way each class will have same number of pixels. For example, I am making 9 classes. So 9 classes will be made in such a way that each class, for example, 1 to 150, 150 to 500, 500 to 1500, 1500 to 3000. So here you can see whatever I have said, you can notice the interval of these classes is not same, but number of pixel in these classes, that will be same. So that is equal frequency classification method. There are other classification methods also, you can see them. So with this I will end the session. Now if you are having some queries related to the measurements, the queries, the classification reclassification process, you can ask.